Okay, so this video is going to focus in on our continuation of our SolidWorks prep, our CSWP prep for Part 3 exam from Engineering Design course. What we're going to go over in this case is we're going to focus in on the sample problem I got from BW Engineering. It's called CSWP1803, Segment 3. It's a PowerPoint. I'm going to use this video here to walk through it. It's towards the bottom of our page here. Before I get going, though, I do need to download the robot gripper because that's going to be the pieces I need to actually do the assembly they're going to have. So I'm going to go ahead and left-click on this. And I'm going to go ahead and open this. And then I'm going to extract all. Let me close that off. I'm going to go ahead and right here, I'm just going to do an extract to. I'm going to put this to my desktop. I'm going to say, okay, let's go here. I'm going to pick a place to put it. I'm actually going to highlight my desktop. Yep, perfect right there. I'm just going to go ahead and say OK. And now that should be extracted to my desktop. This is extremely important when you're doing this. You cannot pull zip files or zipped files into an assembly. They must be extracted so the parts are in full context. So in this case, I can close this down. I've done that part, and now what I'm going to do is go ahead and open up this PowerPoint, get this up and running, and it's opening on my other screen, so I'll slide this over from here and expand out and enable editing. And I'll go ahead, I'm not going to worry about the full screen. Maybe a little bit later I may go to full screen, but in this case right here, again, thank you to BW Engineering for having this out, to be able to use it. But in this case right here, this is what we are going to create. Okay, there'll be a couple parts that we'll have to create. Most of it we'll have to import in and then go through it, and obviously looking at each piece, create it, find the mass, using these dimensions, just kind of buzz through, add on a coordinate system like we've done before, and do a new XYZ coordinate system based upon that. Add in some spur gears based upon what they want us in this case to add for mates. Let's see, go to the next one. We're going to add a couple other pieces on top of that are going to start building up the robotic arms. They want to know, again, what the XYZ is, or center of mass. Then we're going to basically create a sub-assembly, which is pretty common. We're going to create these two parts, put them together into a sub-assembly, find the mass of those two parts together, take that sub-assembly and put it into this assembly here. We're going to have to use, it looks like gear mates. That's going to be new, something you may not have done before, but we'll do gear mates on that. In this case, yep, they're going to ask us to do a gear mate. This is good. They're going to walk us through it, and that's important to understand because what they're going to probably mean in this case, and I've seen this on certain tests, we're going to have to move one arm, and it will automatically, based upon the ratio, move the other arm at a different speed, and then a lot of times we'll either find the angle or distance between after we've made the move. Going on to here, we see this. We need to find our angle X. We've done that before. Go in here and create another sub-assembly that will then add into here along with these pins. Coming down into here, showing us basically the mates of the links, okay, and then finishing off 9 and 10. Here it is. This is where they want us to do some turning and some gear ratio, making these things parallel. And then what is the distance of X in between when this is at a 45-degree angle? And the last question will then be to come in here and move the outer grip and run an interference detection and determine which of these pieces is interfering. Okay, so we have quite a bit to do. So let's go back to the top here. Starting off on this piece here, I'm going to go to this part here and begin making this, this piece in metric. Okay, so in this case, it's going to be made of 1060 alloy, decimal place is 2, fine, and we're going to name it body plate. All right, I'm going to slide this over to my other screen, so this way I can see this a little bit better. And from here, I'm going to go ahead and start up my SolidWorks with a file new and then metric. I'm going to go ahead and start this. I think in my case, I want to go to let's go to the views here. Oops, let's go to this other window. I am going to go ahead on this one, and I think I'm going to go ahead and start this. I think I'm going to go from the right side. I'm going to do a mid-plane extrusion. I'm going to do some cuts, add a piece on the top. So I'm going to try to do mine a little bit different. I'm going to start off creating an L shape here. I'm going to go ahead and take my line tool, basic create up, slightly in, down, over, down, and in. Go ahead and throw some dimensions on here. Looking carefully to see if I've got all my dimensions on here. Looking at this piece here, maybe not. Hold on. I guess I'm going to cancel that out. I'm going to go ahead and start from the top because I'm looking at the other views and it looks like it's the top plane is what they started from. So I'll go ahead and use their guidance here. Not sure why they're putting the origin where they put their origin, but I guess I will go ahead and put it in there. I don't understand what their rationale is. I'm going to go ahead and just create from the top. I'll go ahead and just create an outline of this. I'm going to add a relationship of midplane or midpoint in here and make those coincident. Let's go ahead and make this back in at 74. Distance on this edge here will be 36. I do not like the way they have dimensioned this. This is really inappropriate from my perspective, the way they dimension this. But I'll go ahead and follow the same guidelines. The front end up here is 34. It is a symmetrical part, so a couple things I can do is take this midpoint and make it horizontal to this origin. I can make these two sides equal. Okay, that gives me the beginning of this. I'll go ahead and at this point add in some holes. So I'm going to go ahead and add in these pieces here, a little circle there, a couple up towards the front, one here, another one here, and one back here. Okay, I'm going to go ahead and add some dimensions on this. These are all at 4.5. Don't know why you didn't use the word TYP, but again, I'm not going to argue with how they did this. But I'll make that 4.5, and then I'm going to go with my control key and make all four of these equal to each other. I'm then going to go ahead and add some measurements here from the center point here to the front. Pull this up. It's going to be 7.25 millimeters. Pretty small. Go to 2 decimal places so you can see that. That one's going to be 7.25. These dimensions are horrible, not to be mean, but these dimensioning practices are really, really bad. 7.3 or 23 from the origin to one of these is going to be 11.5. Yeah, that makes sense. It's half of 23, 11.5. I'll make these two here vertical to each other. And then the distance between these two are going to be 53. I will tell you this one here is vertically aligned to that edge right there, that corner, so I'm going to say vertical. Then from the origin to here will be half of, they got 26.75. Oh, I got to change the number, 26.75. And this actually is 53.5. Got to read my numbers better. I'm going to go ahead and change that to 1 decimal. Change this up here to 2 decimals. So you can see the numbers. And last but not least, I'm going to make these two vertical to each other. Vertical. Okay, so now at this point, I'm going to go ahead and look at some of the other pieces. I'll go back to each of the segments. Thickness of this will be 4 millimeters. So I'm going to go ahead at this point, features, extrude, and let's go ahead and go up on this 4 millimeters and check. and then right-click on my material and do a 1060 alloy. Okay, so that starts there. I'll go ahead at this point. I'm going to go ahead and off this back face right here, normal to, and start a new sketch. I'm going to go ahead and sketch the back side of this. So I'm going to go from this point right here up. There's a slight angle in. Go across. Angle down. I'm going to hover to kind of get that to see it. Hopefully it will. There we go. And down. Close it off. And now what we'll do is add some key dimensions here. So it's going to be 26 millimeters tall from here to here. It's going to be here. It's going to be at 10 millimeters tall at an angle of 45 degrees. 45. I'm going to go ahead and do some things here. I'm going to take this corner here and this one here and make them horizontal. Make these 2 points equal, or 2 lines equal. 45, and now it's fully defined. Okay, now the thickness of this one here, trying to find the measurement, 7 millimeters. Okay, so I'm going to do features. And actually, before I do that, I'm going to go to my isometric. I'm going to go forward into this at 7 millimeters. So we're going to go the other way, flip our direction, and go 7 millimeters, and hit my check mark. Okay, looking at my other views, I'm just making sure I've got everything I need. I'll go ahead now. I'm going to start on this top plane right here. I'm going to go ahead and spacebar normal to and start a new sketch. And now basically I'm going to draw a line from this back wall. Can I draw it out? I'm going to draw this right now with sharp angles. I'm going to come back in a moment and add in my, let's see if I can get this to work, okay, like that. Add in my fillets. I'm sorry, I'm stumbling here, just trying to focus in. Now I do know that this line and this line here are collinear, so I'm going to make that collinear, along with this line and this line are collinear, which means they lie on top of each other, so that makes that easy. This line back here is going to take that midpoint and attach it to the origin. So I'm going to say make that coincident, and this total length on this back wall will be 40 millimeters. Okay, that looks pretty good. The distance, okay, I'm looking at this. This is where the slot is at. I'm just trying to figure out where I'm trying to go. 30 millimeters, that does not tell me anything. 36, okay, so that's there. 34 up front, that's not telling me anything. 40, okay, alright, I guess what I'll do first of all is, this is not exactly the best of sketches I've seen. I will go ahead and add some fillets on here and see if I can figure where these are. Radius of 4. What is the big fillet? I'm not seeing that dimension, so I'm sorry I'm stumbling here. I do not see a radius on this unless I am just absolutely missing something here. 30, I'm not sure what that's supposed to be. Is that the slot? I do not see a radius. Okay, going back to this one down here. That's radius 8. I guess I'll go ahead and put the slot in real quick. Use my slot tool. I know this is going to be centered. It's going to be 20 from the front. I apologize, this is taking so long, but these dimensions are not really good. And then from center to center will be 30. And this will have a radius of 8. So that takes care of that. I am going to go ahead and move this down and this down a little bit. I am going to go ahead and highlight this and do a convert. Highlight this one and do a convert because I need these holes to be open. And another convert and one more convert. So that makes that easy. The problem I'm having here is I see I have a radius of 4 in the corners, but I do not see radius of 4. I'm not seeing all these dimensions. I see a radius of 5 somewhere, but this is really not telling me much. Hold on here. Go back up here. Okay. Radius of 5 on the front there. Radius of 5, radius of 4. Okay, this is just not good. Not good dimensioning in any way, shape, or form. Okay, so I guess what I'm going to do here is add a 4mm sketch fillet. I do know these lines are on the same vertical here. I am going to put a 4mm fillet on both of these corners and check. And then I think what I'm going to do is just make this a full round. So I'm going to go to my fillet tool. The problem is I can't do a full round on this. But what I could do, I do know that these circles, I just don't know how big they are. I do know it's 36 to there, but that's concentric. This is not good at all. We are missing some key elements and key dimensions here. This is not thoroughly done, which is not good. It means a lot of stuff is left to guess, and I'm not sure what I'm looking at here. So let me just continue looking through these and see if I can find anything of value that would tell me what's going on. Right now, I am really messed up on these curves, the curves that go right here. Oh, I know what I can tell you. Okay, so this and this corner right here are, oops, control key. Oops, I gotta get out of my sketch. All right, so I have to look at this. These two are vertical to each other. That defines there. And then here, here's what I'm gonna do. I'll do a little trick. This is geometric. I'm going to go here and draw a circle because I know it's centered, and a circle here. And then I'm going to add a tangency to that tangent. And oh, did it work there? Okay, let me try this. Tangent to here. Okay, and then I'm going to take my trim tool. And this is a little old school. This is a little bit more of what I did when I used to do AutoCAD because a lot of it was done this way. But it works. And I get full definition there. So that looks correct. Okay, so that was my solution to this. I got to make, it looks like, in this case, I can tell you right now, collinear, that right there, I'm going to take off of there. Actually, Control Z that. This point here, I need this to be tied into there. So we've right now I'm not sure why an intersection, our tangency, but this is not tangent over here. So let me take this point off, slide this back, and just attach it to that endpoint. There we go. Okay, sorry this is taking so long. Come back over to here, get rid of that point. Oops, this right here. Delete it. Drag and attach, whoop, nope, Did that work? Yes. Okay. So now we're attached. That looks more correct now. So there we go. So now at this point, I see this sitting right here. We're going to go ahead and extrude this up 4 millimeters. As you can see, the first part is already kind of a bear. So I'm going to go up 4 millimeters and hit my check mark. Okay. At this point right here, I'll add some fillets in a moment. Actually, I can do it right now. There's a couple little things I can do. We do have a fillet on the top here. Trying to see what we have for a chamfer, because there is a chamfer. It's a 2 millimeter by 45. So I'm going to do something real quick here. I'm going to go to features. I'm going to go to my fillet tool. We got radius of 5 fillets here. So I'm going to go 5 millimeters on my fillet. I'm going to hit this corner right here. This one. Up here on this edge here. That one back there is okay. I'm going to do the same thing on this. Here. Back here. And back here. Just seeing if there's any others I can see. I think that is it. Hit my check mark. And then I'm going to go ahead and I'm going to put a chamfer all the way around this upper edge. So I'm going to go back to that fillet tool and go chamfer at 2 millimeters by 45 degrees. And I'm going to click on that edge right there. And this goes all the way around that bend there and back all the way there. And I think that's it. Yep, the back stays flat. I'm going to hit my check mark. So here's what I'm looking at this point. Okay, getting close here. So now I've got to add on this back part. So what I'm going to do in this case, it looks like I got to punch a hole in here. So I'm going to go to this back face, start a sketch, spacebar or normal to, and it looks like that hole is going to be a diameter of 16 is what I'm assuming here. So it looks like it's going to be 16. So I'm going to go ahead and vertically go up. And now I got to play the game of figuring out where this is supposed to go. Unfortunately, the dimensions again are very poorly done. There's not a lot of information in here. Diameter 16, 15, okay, 14 tall, 15 deep. I'm not sure what I'm seeing here. And then there's a cut at 10 millimeters. Holy moly. Okay, so I'm going to make the large assumption here, and this is really crappy to make an assumption, but I'm going to assume this is sitting in the middle of this back plate. So I'm going to put this like right in the middle. So if this is 30 millimeters, 34 millimeters, says I have 4 plus 26 plus 4 is 34. I'm going to go from here to here at 17. And I'm going to line this up vertically to my origin and dimension this to 16. And I'm going to do an extruded cut through all. Okay, so that gets me to this point here. That's not too bad. Now this is where it gets a little bit odd. They have a little odd back end here, so we've got to kind of look at this. The first thing I do is go to this face here, do a normal 2, and start a new sketch. And actually, I take that back. I got to get out of this sketch. I'm just realizing the diameter of this circle is actually 20 millimeters. So let me close the sketch out, discard. This is actually 20, not 16. I'm looking at the wrong thing, so this is 20 millimeters. And then from here, the inside circle is 16. Okay, I see what's going on. Now hold on here. What is this? Radius of 14, so is that a diameter of 28? Boy, their dimensioning is really bad. I apologize, you guys. This is not good. I really do apologize. I thought this was a good file. I was all excited to see it because I was thinking, oh, something new. And I'm not too happy with this. Some of the dimensions are really, really, you got to like dig in and look. Then I'm going to go in here and draw a circle that is 16 millimeters. I'm going to have to, add a circle to the center here. Make that one 16. That's my 16 millimeter circle. I need to draw basically a line, kind of across. I'm going to do another one down below. I'm going to, at this point, make a dimension from here to here of 7 millimeters, and from line to line here at 14 millimeters. And then what I'm going to do is take my trimming tool and trim off this part of the circle here, this part of the circle here, this line, that line, this line, bottom part of the circle, that line, and this part of the circle, and that line there. Okay, so I get 2 extrusions here. Now, if that's 16, okay, and then I have to come back and I got to fix something and go right with that circle. So in just a second here, I'm going to now extrude this out. Looking at this, it's going to be extruded 15 millimeters. So right now I'm going to go Features, Extrude Boss Base. We're going to go 15 millimeters. Make a check mark. Now I got to go back in here. That's right. Okay, that worked. That's what it should look like. There should be an overlap there. Okay, now what I'm going to do from here is I'm going to cut out, basically I'm going to go to this top surface right here, I am assuming. I'm just trying to get all the views I possibly can. I guess what I'll do is go to this face here. I am going to just trying to find what I'm looking for here. Okay, that's 16, and then, oh, that's 16. Wait a minute, I'm just totally confused here. Okay, so what size am I looking at here? So sorry, I'm trying to get another view of this. That's 16. All right, then what is the inside? Oh, okay, so then I got to come back. Man, they make this really hard. Okay, I'm going to go here, start a sketch. I got to convert this entity right here and do a convert, and then I'm going to do, hold on. I don't want to do this. Take that back, delete. I'm going to go ahead and highlight this inside face and do a convert. So I get the full circle. And then I'm going to cut this circle 5 millimeters out. Man, they make this hard. Sorry for the extra discussion here, but man, this is just not a very good, well drawn the way they've done this. Okay, so there's that. That's more what I'm looking for. Okay. Then it says I have to finish off with a 1 millimeter fillets on the corners here. So I'm going to go here with Feature, Fillet, 1 millimeter, and it wants those fillets on these sharp edges here and here. And I think on the other side, here and here. Just trying to look if there's anything else I need to add in here. I hit my check mark, spacebar isometric. Just going to take a real quick peek at the original part of the top. Just double checking I'm looking the same, and I think I've got it the way it's supposed to be. Okay, so I'm going to quickly do a file save as. I'm going to save this out to my, I guess in this case, my desktop. I'm going to call this, they want to name this body plate. So I'm going to name this as body plate. And I'm going to put this on a robot gripper, just as to remind me where this is at. Okay. All right, so now what it wants is you to go in here and do your evaluate and your mass properties. Okay, and then that gives you your answer there. Okay. And so that's not too bad. It looks like it was easy to find the answer. So now I've got my first part. So now part number 1 is done. Okay, go into the assessment, pick the right answer, and then let's move on to part number 2. Now it wants us to add a coordinate system. All right, now again, they do this deliberately where they throw it to the backside, so you got to reorient this kind of so you can get this into a position where you can see this actual corner. Okay, they have a bad habit of kind of rotating you around. I guess I should have probably really spent some time looking how this would have been oriented would have been better. And actually my orientation may be okay, and it is. So actually this makes it easy because the way I drew it, it's going to be right on this corner. So I'm going to go into my features, reference geometry, coordinate system, pick on this corner, and I just want to verify the X, Y, and Z. So it looks like my Z is going out the back, Y is going up, X is going in this direction here. So now what I got to do is I'm going to take the Z and line it with that line there, and that's all I have to do. Perfect. Y is going up, Z is coming out here to the right, X is going back into the part. That's exactly what I want. So I'm going to hit my coordinates or my check mark, and now I'm going to go up to the all-seeing eye because I want to see my coordinate system. Okay, there it is. All right, now again, you go to your evaluate, you go to your mass properties, and this is where, again, on the last assignment I gave you, I had several of you continue to forget to do this. You put this on here, but your X, Y, and Z is now incorrect because you did not change it to your current coordinate system. And this is your new coordinate system. Okay, so I'm going to give this one to you for free. So you got negative 30, or you got 37.00, 14.36, and negative 24.13. Okay, that takes care of the X, Y, and Z for this part. So now it takes care of question number 2. So now what I want to do is go over to part number 3. So I'm going to go over here. Part number 3 says now we're going to add these 2 pieces here. So add the 2 spur gears, and then what is the mass based upon this coordinate system again. So I'm going to go ahead and start adding that in. I'm going to go over here. I'm going to go into File New, because we are now going to create an assembly, tutorial, assemb, and OK. I'm going to bring in my body plate as my starting part. I am now going to go ahead and start going into my assembly and inserting components. Now in this case, I have the folder on my desktop. Okay, so hopefully I can find my robot gripper. Okay, robotic arm, robot, where's my robot gripper? We are on the desktop, correct? Where did you go? Right here, robot gripper, there we go. Okay, I'm going to go to my spur gear and say open. I'm going to drop one here. Okay, now in this case, let me expand this out to full screen, just looking where these are at. Okay, so where are we looking here? Because it's really hard to see some of this stuff sometimes. The little notches will be parallel. Okay, so we got to be really explicit here. So I'm going to take and rotate this thing around. So I'm going to start with a rotate component. So I can get this kind of in this position here. Where the pins are up. I don't think, yep, I guess it's either way, it's fine. And then I'm going to hold my control key and pull a second one of these. And hopefully that'll make it work. It did, so I'm going to drag this one over. Like so, and like so. Okay, so I've got 2 of these. Now, we're going to add a concentric mate. We're lining it up with these back holes right here. So I'm going to start with this one here. Mate, lined up with that hole right there. Gives me concentric. Check. This top face right here, we're going to make flush with that face right there. Okay, and check. Now, looking at this, okay, we're still able to move, so we're going to do the exact same procedure on the other side. I'm sorry, it gets a little bit further away. Oops, nope, that's not what I want. Inside here, I'm going to mate that, okay, to this other hole here. And same thing, I'm going to kind of lift this one up. Actually, somehow, oh, nope, as I say, they get locked together. And then I'm going to take this one here and put it to that face there with coincident. Okay, I got to get out of this for a second. Something's going on. Oh, somehow I made these 2 faces. I got to delete that. I was wondering what was going on. Somehow those end up being concentric or coincident to each other. I was wondering why they're moving together. I should have known that right away. Something wasn't right. Okay, coming back in, put that in its place, and now what I've got is I got my 2 gears independent of each other, but basically easy to spin in here. Okay, now we're not done quite yet. I'm actually going to go through, I don't know if I can do this. I don't know if I can hide this surface. I got to see something here. If I can hide this surface. Change transparency. Maybe I'll just do that. There we go. I can make it see-through. And then what I want to do is now we got to be really explicit here. So this one here, okay, so when we're looking at this, you got to really pay attention to what they're doing, because this test is all about detail. Okay, I'm going to go to my top view for a second. If you look at the top view over here, I'm just going to slide this over. I'm going to make this full screen for a second. But if you look, you got to be paying attention. It's telling you to take this notch. So this little peg over here has got to be to the right. And so this notch over here, this little keyway has got to be parallel to this side. And then vice versa. So we got to make sure that this one is also parallel to this side. So this little pin is to the outside. Really important you pay attention to exactly how they set this up, because we're going to test you on this later when they basically bring in and we have to do gear mates. So I'm going to take that edge right there. I'm going to go to mate and make it parallel to that one there. Okay, same with this over here. I'm just going to go ahead and rotate it, make it really easy on myself, but I'm going to take that line, this line here, and this face back here, and I'm going to hit my check mark. Okay, and with that done, isometric, and I'm going to come back, and I'm going to change my transparency back. So now I'm back to solid. Okay, now I'm going to call this spur gear, I want to name this as a let's call this robot, I'm just going to call this a robot gripper assembly. Okay, I'm just going to start saving this. So I'm going to do a file, save as. I'm going to name this robot gripper assembly. Okay, so now all I want you to do is save all. I'm going to just double check there's material on my spur gears. There is. They're made of both brass. So now what I want, so let me go ahead. Now we have to, again, remember in the assembly, I can't see my coordinate system over here. So again, I have to re-add it on. So I have to go into my reference geometry, coordinate system, pick on this corner, highlight the z-axis, and click on that line. Okay? Now, with that done, I'm going to go ahead to the all-seeing eye here and make my coordinate systems stay on. There is my coordinate system. So now again, I want you to go into your mass properties, or excuse me, you evaluate your mass properties, and now you need to come up with a new XYZ based upon this coordinate system. Do not forget to switch that over. I'm not going to show this to you. You're going to enter your answers into the assessment. Okay? So that takes care of question number 3. So let's move to the next one. Question number 4. All right, question number 4. Now we're going to add on these two pieces here. So again, looks like they're going to be coincident or concentric. So that pin there, and then we're also going to make sure that they're flush to the top surface of the spur gear. Okay, and then we're going to figure out from this mass what is the new, and these are going to have to be straight out like they are. Okay, what will be the new mass or the XYZ center of mass of this? All right, so sliding that over, let's go back and assembly, insert components, browse for our parts in that folder. So I'm going to go ahead, I like my pictures to be big. Okay, I like to make sure I can see. I'm more a visual person anyways. So I'm going to go here and I'm going to pick on the gear link. Is that right? Yeah, the gear link. Okay, I'm going to open that up, bring that in here. I'm going to go ahead at the same time, hold my control key and drag a second one. And now I'm going to start adding in the key pieces that I need. Okay, so first and foremost, I'm going to go ahead, highlight this inside face, turn my mate tool, and that face is going to be concentric to that basically nub right there, or part of the spur gear. Okay, the boss. All right. I'm also going to make sure that this face right here, or this circle here, is concentric to that one. And then I'm going to go ahead and make sure that this bottom face here is coincident to that face there. So this should be perfectly wrapped tight around the spur gear with the pins popping through these two holes, coming out perfectly at a 90-degree angle. Okay, so that one is done. Repeat the procedure on the other side. Go over here and take this here. Go to this right there. Same thing. Rotating over. I'm going to take this piece. Oops. Get that up here so I can see it. Come on. There we go. Take the inside of that to the outside of this pin. And then finish off by taking the bottom face of this gripper piece and making it flush with our spur gear. Okay, so there is our new piece. I'm going to do a Control S to save and say Save All. And now what it wants us to do is, again, using the coordinate system 1 we created, go to your Evaluate and find the mass properties and put in the XYZ for coordinate system 1 into the assessment. Okay? All right, now the next piece. Okay, going to question number 5. Now we're going to create a subassembly here. So question number 5 is going to be where we're taking and bringing 2 more parts in. So we're going to create a subassembly we're going to call a crankshaft or drive shaft subassembly. Okay, drive shaft. All right, so we're just going to bring 2 parts together, make sure we made it the way they want them to, which is going to be with some coincident. Okay, and then we're going to concentric these holes. Make sure these are all touching as they're supposed to be. And then that way we'll take from here, we'll find the mass. Okay, there's no center mass, just find straight up mass on this. So going into here, I'm just going to go ahead and do a file new. We're going to go ahead and open up a new assembly because we're going to create a subassembly here. This is what this is called. I'm going to go browse for the 2 parts I need and bring them in. First one I need is a spindle. Okay. And then I'm going to insert the worm gear. All right, now I'm going to assemble these together. I'm going to rotate the component. I'm kind of trying to make it the same here. I'm just going to kind of rotate it so it's in the same kind of similar position. All right, so now what I want to do is it wants us to go ahead and make this face here and that face there. Oops, I got to mate them. Sorry. Try my mate tool. Mate that. Oh, I can't see. Sorry. To this face here. Okay, that looks good there. Yeah, then we got to do a side face. I'm going to take this face here. I'm going to mate it into that face over here, like so. So now this is at least on the part. And then, except for this is the problem, I need to actually undo this because, delete these, because I didn't think about this. I probably should have done, I need to rotate this part so that the holes are in the right position. I did not do that. So right now, I'm actually going to do a quick rotate again and see if I can rotate this a little bit better. That looks a little bit better. And come back into this one more time, making sure I get the right surfaces touching each other. So that's going to be that surface there. And then let's go ahead and hit this one here to that one over there. And now it looks like we're lined up to where I can line up my hole here to the hole here. Okay, so there's my concentric. Go to my isometric view, and there is my part. Okay, this is going to be called File Save As. I'm going to call this Drive Shafts Subassembly. Drive Shaft Subassembly. Okay, and save. All right, save all. Cast alloy steel and plain carbon steel. So then you go up and you will find your mass. You're just going to simply go to Evaluate. I'll help you with this one. Mass properties. There is your current mass. Okay. Go to the assessment, pick the correct answer, and move on. Okay. So that takes us through question number 5. All right. So now coming back over, I am on question number 6. All right. Question number 6. We're going to bring the subassembly in, and we are going to assemble it using the mates. They have a parallel, a concentric, and a coincident. And then from there, we are going to use or find the center of mass based upon the coordinate system 1. Okay, so let's go ahead and do that. So again, I'm going to go back into Control Tab and Robot Gripper Assembly. I'm now going to go ahead and do Insert Components, but I'm going to bring in my drive shaft subassembly. Okay. Now, in this case here, I'm just going to do a quick rotate this around, put this towards the back, I guess. I've got to think about where they want this. Oh, I see where it's at. So the first thing we're going to do is take and make this flat little piece right here. I'm going to go mate, and that is going to become parallel to that face right there. Okay, we're going to make that parallel. All right. I'm going to pull this thing back a little bit, and then we're going to go ahead and take this part of our motor and to the inside here and make it concentric. And then from there, we are going to take this face right here and make it coincident to this face right here. And so now, at this point, here is my current assembly. Okay, minimize some of this stuff. All right, so I'm going to do a quick save because this is my updated gripper. And there is your current piece. Now, you'll need to go into your evaluate and find your new current X, Y, and Z for this part. Okay, so you're going to go ahead, you're going to go to your evaluate, you're going to make sure that the X, Y, Z coordinate system number 1 is the one you use, and then you're going to go to the assessment and fill in the X, Y, and Z for problem number 6. Okay, so going to the next one. Problem number 6, okay, now, this is going to be for problem number 6. Oops, we're not done yet. There are 2 more mechanical, okay, there are 2 more mechanical mates for the gears, for worm gear and spur gears to find what permits next slide. What's the center of mass system with respect to the new coordinate system? So, I am assuming that this part is for this. Your center of mass should be for this part right here. No, knob or drive simultaneously, or check a movement, a couple of parallel lines. Parallel mates need to be suppressed. Okay, so we get rid of our parallel mates. But at this point, I believe your XYZ, yeah, your XYZ for this answer here is off of this setup right here. Okay, so let's go into this next one. So what we're going to do is add some gear mates. Okay, in order to make this work, we're going to have to actually get rid of, in this case, we're going to have to turn off our parallel mates. All right, because otherwise it's locked. So we've got to actually go in here and turn off. Over here, I see a parallel. What is this parallel for? That parallel, oh, that's for those teeth. Okay, so this parallel mate and this parallel, all these parallel mates are going to have to be suppressed. Okay, there's a reason for this, including this one here, because what we want to have happen is, and we're going to add a gear mate here, and what will happen is when I spin this motor, these arms will move in correspondence to our gear mates. Okay, so what I'm going to do is we are actually going to go to our mate tool. I'm actually going to right click on this first and make this transparency so we can see through it. Okay, and actually if we really wanted to, I can actually suppress or hide this. Instead of doing this, we can actually, in this case, suppress like this so we can see this. And now what I'm going to do real quickly is go to my mate tools. And now we're going to go to what are called mechanical mates. Okay, these are mechanical, and we're going to go to what's called a gear mate. So we got all kinds of cool things. You can make cams, you can do slot mates, hinge mates, you can do gear mates, rack and pinion, screw mates, universal joints. There's a whole bunch of different things you can do mechanically. We are going to do a gear mate. Okay, what we're going to basically do is we're going to tell it, we're going to give this a gear ratio. Okay, so it's really important we got to give this thing a gear ratio here. So looking at this, we're going to do, and I don't know if these are actually in the right spots or not. I'm kind of looking at this. This doesn't look really good. So I'm going to, Control Z that. I actually got to come back in here. I'm going to come and unsuppress my base because I think I just lost, yeah, there we go. Okay, so at this point here, I'm just going to make this kind of see-through. I'm going to go back and change the transparency. Actually, what I probably guess I could do is just hide the component. Nope, Control Z that. That's not what I wanted to do. I wanted to hide this component, so I'm just going to hide it, not suppress it, just hide it, because I think that's, yeah, that gives us everything we need. I'm actually going to kind of line these up now. The reason this is kind of fun is because we're going to do this with our gear car project, and we do it to the end of the year. Okay, so this one looks pretty good. I don't know why this one didn't quite go there, the same spot, but I'm just going to go ahead and kind of put it in that position there. Okay, hopefully that won't screw it up too much. Who knows? Maybe in all said and done, I'll probably end up screwing it up, but it is what it is, and we'll make it work. But what you're going to do is you're going to go to your gear mate tool, okay, and then from here you're going to go to your mates, you're going to go mechanical mates, so you're going to down arrow, gear mate. Now what they want us to do is they want us to take the shaft right here of our worm gear, okay, and then they're going to go ahead and they want us to take the shaft of one of our spur gears, okay, and the ratio should be 20, so this teeth diameter here should be 20, and that's correct, and the teeth diameter here should be 15, okay, they want you to keep it at 20 to 15, and that's fine. So when you do that, and if you hit your check mark, I'll come back and turn my little thing back on. Let me go from hide and show that back. So I'm going to go here, transparency, and turn it back on. If I turn this, you can see that one is working by itself. And the reason that happened, and that's on me, Control Z this real quick, okay? The reason that happened is because when I did my mates again, I forgot I have to do the mate on both of those gears. It's not just one, it has to be on both. I screwed that up, that's on me, so I'm going to go ahead real quickly here. I'm going to do the hide again. I'm going to come back into my mates and do the same thing again. This one, oops, sorry, go to my mechanical and to my gear, and I'm going to take that one there at 20 and this one here at 15. Hit your check mark, close out your mates, unhide the body. So there it is, isometric, and now if I twist this, they should be working together. Now in this case, it looks like they're kind of they're backwards, and what that means is one of them. So what I'll do in this case is go back and edit one of these gear mates and reverse it. Okay, so I should be able to go reverse here, I think. And if I do that, yeah, that makes them work together. Okay, so one has to be reversed to the other. So as I twist it, it will work. Okay, so now you can see the robot arm will work as I twist this around. All right, so that's all there is to it. That's a simple gear mate. We will end up doing this in our gear car project. Hopefully we'll get to do it at the end of the year. You actually made it. You can animate it. You can make your wheels spin. It's pretty cool. I can add a simple motor on this, have this spin around. You can watch the arm go back and forth and close. So I'm done with my mates. I'm going to do a quick control save. And now what it wants us to do in question number 10 is we're going to take this that we just created. Okay, we're going to create this right now, and we are going to go in here on this one, and we're going to suppress the two parallel mates, the mechanical gear mates are working, then rotate the spline shaft as shown here. So what we're going to do is they want us to suppress the two parallel mates. We've already done that. They want us to rotate knob to find the collision. Okay, so again, that collision piece, all right, save all, rebuild and save document. Okay, we're going to do a move and a collision detection. Okay, highlight faces, stop on collision. So all we're going to do is we are going to move this. Oh, okay, already stopped. Let me go back the other way. I don't know if okay, I think I already, okay, go back. Oh, come on, man. You can see this is kind of a pain. It's really slow for some reason. I don't know what this is doing. Go the other way, I guess, and then stop on collision. Oh, what? Did the collision not work? Hold on here. Let me do that again. Okay, oh, stop on collision. I don't know why that happened. All right, here we go. Okay, so stop on collision. I don't know why. Okay, we're having a real process issue here. Okay. So in this case, I'm going to bring this in until it stops, which it's not doing for some reason. Okay, let me escape out of this and start this again. Okay, so move component, collision detection, stop on collision. I should be able to rotate this, and it should stop on collision, but it's not doing it. Okay, the model started in colliding position, stop, collision has been disabled. Okay, so let's get this back into a position that'll work. All right, so what happened there is I already had it in a position where it was colliding with something. Okay, so it already wouldn't let me work with it. All right, so I'm going to do collision detection again, stop on collision, and I should rotate to the right. It should stop. Okay, it's not doing it because we have an error somewhere. Not sure where the error is located. So let me do a quick rebuild here. Try this again. I don't know where we have a collision. Not sure. Use collision detection with stop at collision turned on. In options, remove spur gears for collision detection due to its... Oh, there we go. Got to read directions. Look at this, boys and girls. This is why Mr. Combs would fail this test. Read directions. In options, remove spur gears for collision detection due to its inherent contact characteristic. What it's saying is there's already collision between the worm gear and the spur gear. Of course, they're meshed together. I did not ignore those, so I apologize. That's why I'm screwing this up. Let's try that one more time. All right. Collect my thoughts. Take a breath. Move component. Okay. Collision detection. Stop on collision. Ignore. I don't know how they want us to do this. Dynamic clearance, check clearance between, oh, resume drag, okay, rotate, collision detection, oh, these components, I guess, okay, so free drag, check between, how do you ignore, turn that off, okay, so it says in this case in options, remove spur gears for collision detection. Remove spur gears. Okay. Check these components. So it would be this, 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 and that would be it. All I want to do is I want these three here. I don't want to take in the gears. I'm not going to worry about this one either, so I guess I'll go here. And now we'll resume drag and go to here, and there's our stop. Okay. I've never done that before, so and I had never created a video for this, so this is good. Okay, so now from there, we got to measure our angle. So I'm going to stop right there, go to my top view. Oops, sorry. Top view. It wants us to measure the angle. So now in this case, what we're going to do is to go to my evaluate, measure tool. Measure from that edge to that edge, and I get my angle right here. Okay, so there is your angle. All right, so that is what you're going to enter in your assessment, is that angle number right there into question number 7 of the assessment. Okay, going to question number 8. All right, so here's number 8. Getting there. Got two more after this. All right, we're moving right along. All right. From here, we're going to go to and bring in another subassembly. So I'm going to have to start another one, bring the grippers together, and then we're going to add those into the main assembly. Okay, we're going to call this a grip assembly, and then we'll add that into the main assembly. So going into here, you can see this is pretty long. So I'm going to do a file new, assembly, okay, and I'm going to go ahead and browse the 2 parts I need, which is this one and this one. I'm going to highlight both and say open. I'm going to bring this one here and this one here. Okay, and I'm just going to go ahead. In this case, we need the teeth on the same side. Perfect. So what I'm going to do at this point, just do a quick rebuild. Oops. I don't know what the heck this is doing. Oh, I did mask properties. What am I doing? Assembly, mate, until I'm getting tired. This is going to be concentric, and then we have coincident and parallel. Okay, and then this face right here is going to be coincident to that face right there, and then they want us to make that face there and this face there parallel. All right, so if we're looking from the isometric, there is our final piece. All right, now exit out of the mate, quickly do a file save as. We're going to save this as gripper subassembly, and save. Save all. All right, now go back into my final assembly. So I'm going to go back into my robot gripper assembly. All right, at this point I can move this around. I'm going to bring these forward. Spacebar isometric. Go to my insert components, and we're going to bring in our gripper subassembly. Okay. Control key, I'm going to grab, Control Z. I don't want that. I'm going to go over here to my left. Close these down a little bit, and where I see gripper subassembly, I'm going to hold my control key and grab it and drag it out on the desktop. Okay. Now, we're going to go ahead, in this case, I'm just going to go ahead and start mating this. I got to look at where these are at. Oh, we got to bring in some more stuff. Sorry, we got more stuff to bring in. I also need to insert, we got more components to bring in. Browse, we need this piece here, open. We need 2 of those. Okay, got those. I'm going to go ahead and start with getting those in place first. So I'm going to take the inside of this hole here. I'm going to mate it to the inside of that hole there. Okay, check mark. These are also going to be, this is a good question. Okay, so from there, I will take and mate that right there to the inside of this hole here. All right, that will take and be concentric. Looks like then also this will be, I'm just trying to make sure, oh, here we go. I gotta look at the next slide. You gotta look at the slide 13 here. Okay, so then that's gonna touch face to face. All right, so then in this case, I go check. This top face here is gonna touch that top face there. Perfect. We're gonna take and rotate that out a little bit. We'll add a concentric here to here. Okay, I'm going to reverse that. Don't know why I did that. Oops, nope. Okay, go back. Okay. Let me do a quick check mark there. Let me see what we got going. Okay, so it should look more like, there we go. Okay, and then finish this off with that face right there, flush with that face right there. Okay, so that gives me one robot grip right here. Okay, do the same thing on the other side. I'm going to go ahead and start with the gripper here, and I want that gripper lined up with, this hole right here. Okay, perfect. I'm going to take that face right there and flush it up with that face right there. Except for, here's the problem. Everyone see what I did wrong? I need to undo, and I need to get rid of this concentric here. Actually, I can maybe flip it. There we go. Can I do it that way? Yes, sir. Okay, flipped it over. And now I'll take this here and flip this over to here. And check. Okay, so that gives me at least something that looks, whoa. Dang. Okay, looks somewhat like a robot arm, but it's kind of spastic, that's for sure. Okay, do this. All right. Now, sorry for all the side comment there. I'm going to take this one here and line it up with the inside of that hole there. I am then going to take this one up here and line it up with this hole right here. And finish off by taking this inside face of that piece there, flush to that piece right there, and check. Okay, so now, if you're looking at this, these two should be moving together, okay, but we're not quite done. We're going to add in our 4 pins. So I need to insert some more components. Okay, so I'm going to go browse, and the pins I'm going to need are this one right here. All right, I'm going to drop one right here. I'm going to take my control key and drag another one there. Drag another one over here. Drag another one over here. And now, using my mate tool, one right there. I'm just going to go ahead and add all my concentrics first. Oh, wait. Dang it. I gotta undo. Dang it. Undo. Delete. It's not where I want them. God, I'm getting tired, you can tell. All right. This does not belong there. These all go into this piece up here. Okay, so my fault. So I got to do this again. So I'm going to go back and make this pin inside that hole. This one inside that hole. This one into inside that hole. This one inside that hole. I'm going to actually slide that one up. Okay, and then last but not least, bottom face here to this face here. Check. Lots of mates. Lots of time. As you can see, we're already over an hour's time here, and you take away a little bit of the talking, we're probably approaching an hour on this. And I believe this test is only 80 minutes, so you got to be aware of your time here. So we'd be getting really close. But this is a good indication of pretty much how the test is. So it's really it's your knowledge of the advanced mates, okay, and being able to quickly produce parts for your assemblies and then making adjustments. All right, so there are all my pieces. I'm just going to double check I have everything correct. It looks like I got my 4 pins. I've got all my things correct. And so the last question here is question number 9. Wait, is this what it wants? Oh, so in this case, question number 8, it wants us to go in here. What's the center of mass system with respect to the coordinate system? Okay, add subassembly gripper and all the parts are shown here. See next slide. Okay, and define the appropriate mates as shown here. All right, so I'm not quite sure if I should be putting the parallel mates back on. And realizing now that the reason I have to make a change here is to get your XYZ, I can't guess. I need redirections. Again, this is where you have to pay attention to the details. It says right here, suppress the mechanical gear mates and unsuppress the other parallel mates. So we have to go back to where we were in question 7, where we had the parallel mates on, before we put on the gear mates. So little things you have to be really, really aware of. You have to go back into your mates. So I'm going to expand these. I see a lot of stop signs, so I'm going to do a quick rebuild here. And again, that's really important. This is where they get you on these problems, because they throw those little notes in there, and if you don't pay attention, it's easy to get yourself really caught really fast. Okay, so what I'm going to do is suppress the gear mates. So those are gone. Suppress, so those 2 are gone. Unsuppress the parallel mates, putting basically the piece back into its proper position that we had in question 7. Okay, so now from here it wants you to evaluate the X, Y, and Z. So now we have it in the correct position. That's what you see right here, where these are back at perfectly 90-degree angles. Okay, now it wants to know what is the center of mass based upon that coordinate system we added earlier. Okay, so that takes care of question number 8. All right, enter that into the assessment. So let's look at number 9. So number 9 says make a grip assembly flexible. So we got to make this flexible, this grip assembly flexible. Delete the parallel mates in the subassembly grip assembly. Okay, so we got to get rid of these parallel mates. Make grip assembly flexible. Add 2 parallel mates between the outer grip surfaces of the body. Okay, so we got to do parallel mate here. Then rotate the knob of drive shaft in counterclockwise direction by 45 degrees. What's the distance between the grips? Okay, let's go through this. Okay, so you can see they're challenging us again. So first thing it says here, if I look at this right, it says make grip assembly flexible. Okay, so what I like to do is go up into the actual design tree, grip subassembly. Okay, if you right click on this, you go in and you say right here, make subassembly flexible. What that will do is it'll allow it to flex. Okay, it allows it to move once we get rid of the parallel mates. All right, so we have to get rid of it. It says delete the parallel mates in the subassembly. So what we have to do is go here. I'm just going to go ahead and suppress, or actually in this case, I guess delete. I don't know if we can do that or not. I guess we're going to have to go back into the subassembly and delete it. I'm going to go to here and do the same thing, make it flexible. Okay. This one here, I don't think I can delete. I can't. So what we'll do instead, edit feature. I don't know if I can do that. What we'll do instead is I'm not going to go here. I'm just going to delete it by going into and getting out of. I'm going to Control Tab to here, go to my mates. I want to go ahead and suppress this right now and hit save. I'm going to go Control Tab again and come back into my assembly, say yes to update. Now these should be flexible. Okay, so they should be able to move on their own. All right, that's important there. This should now be able to move based upon all this. So all this should be able to, oh, I got to suppress, okay, wait. Delete the parallel mates and simplicity grip assembly. What the hell? Okay, delete, add the 2 parallel mates between the outer grip surfaces. Okay, so they got, okay, so now what we got to do is add 2, okay, delete the parallel mates and subassembly. I think this is where we got to go back and suppress again. Okay, hold on here. So we get rid of this, but I need to rotate this, but we have to get rid of, in this case, we have to go back, and this is where it gets really confusing. Sometimes they don't give you very good wording here, but this is now where I got to go back, add my gear mates back on. Okay, so I got to go here and suppress that parallel, suppress this parallel again, and suppress this parallel again, and then unsuppress my gear mates, because I have to turn this so it all works together, and then I have to go here and turn it clockwise. Yeah, rotate knob clockwise 45 degrees. So I'm going to go to here and go to my right side view, and I'm going to add a mate, a 45 degree angle mate, between this surface here and this surface here. I am going to go here and make an angle mate of 45 degrees. Oops, nope, don't do that. Sorry, flip dimension. Yeah, there we go. And check. Okay, now why did that not work? Angle of 45. Okay, so my gear mates are messed up. Alright, let me Control Z that. And Control Z one more time. Okay, so undo my gear mates, unsuppress. Alright. So now I should be able to rotate this, yeah. Now does it say, wait, rotate, oh, then rotate the knob of the drive shaft and counterclockwise. Urgh! But look at what it says right here, rotate knob 45 degree clockwise. Oh my gosh. Okay, so this is so stupid. Okay, let me add this in real quick. I'm going to take and add a mate between this and this. Okay, of 45 degrees. And flip that. Nope. Reverse, flip dimension. That should be 45 degrees, okay, from that surface. Counterclockwise. All right, I don't know why. I mean, again, sometimes if you look at this, and let me just point this out so you don't get confused. Read this carefully. It says now, rotate the knob of the drive shaft counterclockwise direction by 45. And then it says right here, rotate knob 45 degrees clockwise. Okay, so you can see there's a kind of a disconnect there. All right, so it's a little bit screwed up. I don't know why they say that. It's just a typo. It must be. Okay, that's where I was getting confused. And then they want us to come in here, turn on our mate tool, and make these two little faces here parallel to each other. Okay, like so. And then from there, they want us to also make this right here not only parallel to each other, they want us to make it parallel to that face there. Okay, so now we've got this where we want it. So now what it wants us to do here is it wants us to measure, and I'm going to do this from a top view. Top view. It wants us to measure the distance from this edge here, this point here, to that point there. Okay, so what do I got to do? I'm going to go to Evaluate and use my Measure tool. And I'm going to measure from this distance right here to this distance right here. And I get a distance of 1.81 inches. Okay, it only wants to do 2 decimal places. All right, so that's what you're going to put in for that distance X, the distance right there. All right, that should be all you have to do. If not, you can also do it from face to face. I could do it from, in this case right here, I could do again the measuring tool. I could say from that midpoint there to, let's say, we're going to be on the same face, to that midpoint, let's say right there. And you get the same thing, 1.81 inches. All right. This, I know this robot gripper, I've seen this very similar on the test before. So you've got to understand what I'm doing here. So you may want to practice this a couple times. Okay. So at that point right there, I'm going to do a quick control save because we've got a lot of work done here. Don't want to lose any of this. Rebuild the document because that puts us on question number 10. Okay, last question of these, and now we're an hour and 15 minutes into this. So we're getting close to where we're like in the last 5 minutes of your exam. So now what it says is the last thing we'll do is interference detection. Okay, so what I'm going to do in this case is I go here to my interference detection. Okay, it says, all right, keep all the configurations in question 9, so we're not changing. Then create distance mate 38 millimeters with top surface of outer grip. Okay, so what it wants us to do here is we've got to add another mate. So I'm going to add a distance mate. God, a lot of mates. A distance mate between here and this face. We are going to make that a distance of 38 millimeters. Okay, and check. All right. Try to do it for both. Then create distance mate with the top surface of the outer grip and the top surface of the body C image. Okay, so which parts of the, okay, so then I got to do, I guess do the same thing here. Go here, in this face here, and do 38 millimeters. Okay, so in this case, why can't I do this? No. Okay, I'm not sure what's going on here. Oh man, let me Control Z that. That just blew up. Control Tab, dang it. What happened here? Control Z. Okay, so what is going on here? So if I go here, but I have to get rid of this angle. You have to suppress this angle. Keep all the configuration in question 9, then create distance mate. Okay, so this angle has to change. I have to suppress this angle. So I'm going to suppress that angle because that cannot work. What the hell? Okay, make that 38 degrees or 38 millimeters. There we go. So you have to suppress it, which makes no sense. Use interference detection. Okay. The only box that should be checked in the interference is make the options interference. Okay, so from here we're going to go to not assembly, but we're going to go to evaluate interference detection. And we're going to go here to where make interfering parts transparent, and you're going to do a calculate. And now here's all the pieces have interference, okay? In this case, it says which parts of interference check all that apply. So let's go and expand it. So I see spur gear. Okay, now in this case, we're going to ignore the spur gear. These are going to determine the collision parts. The only batch should be checked under detection of okay, transparency. So what I would have probably done here is I would exclude components. So what I'm going to do here is I'm going to go to exclude components. And the components I'm going to exclude on this are going to be the worm gear. So I'm going to go here and exclude the spur gears and the worm gear because those are naturally going to have automatic interferences. Okay, so now I hit calculate again. And now look, it took a lot of them away. All right, so I'm going to expand it. I see gear link 1, okay, and grip 2. Okay, so I see gear link and grip, which I'm not sure which is which. I guess it's grip, inner grip, grip 2. Okay, go here, gear link, okay, grip. Go here, expand this out. I get body plate and gear link. Okay, and then I get from here, expand this out, body plate and gear link. Okay, so it looks like we have gear link, body plate, inside inner grip, grip 2, and where the other one was. There was like one more. Okay, so what you would do then is you go into the assessment. You're going to check all the boxes that work for this. So worm gear and spur gear have to be excluded in detection, which is what we just did. And at that point, that finishes up this practice exam. Okay, so at this point, you are done. And that took us exactly 1 hour and 19 minutes and 45 seconds at this point. and the test will be ending at any moment. So hopefully you'll be able to submit this in and get a perfect score. Okay, so use this video to your advantage. I'm sorry it's so long, but this is a pretty in-depth. Make sure you understand how to do this one. I have seen this one on the exam before, so be ready for it. Okay, with that said, good luck. If you have any questions, do not hesitate to ask. Talk to you soon.